Morning, mathematicians. We are back. You guys are good at probability. You guys are having no problems at all. Everyone is understanding the concepts. You have watched the strategy video, and you know that this is what you are looking for or what you want. How many of them? How many looking for / want? And this is how many you could get. How many different things you could get. You guys have got it. The chance of me eating some junk food today is about 1 out of 2, about half. The chance of me cooking dinner tonight, I would say 1 out of 100. Maybe there are 100 different things that I could eat for dinner. 99 of them that I want to eat are takeaway foods. And so that one out of 100 where I actually cook is the only chance of me cooking and eating my own cooking tonight. That's a joke. I'll probably have to cook. Now, I just want to make sure, year fives, that this strategy makes sense to you in some different situations. Because I saw some people getting this question wrong in sipping or charging, I can't remember. But basically there'd be a spinner and it would have 6 segments like that. It would have A, B, C, D. And it said, what is the chance of getting an A? We have, using this strategy, how many of the things are there that we're looking for? There's 3 A's, sorry. So we have 3 out of something. How many different things could we get? 1, 2, 3, 4, 5, 6. There are 6 different things we could get. So the chance of getting an A is 3 out of 6. And if we simplify that, which is what I'm going to talk about in a sec, that equals 1 out of 2. Otherwise known as an even chance. So, I just want to make sure that when you are counting up how many there are of what you're looking for, and also how many different things you could get, that you think about it like that. Simplifying fractions, year 5, we have already done this. We've made them speak the same language. So, if I've got like 3 out of 6, actually let's choose a new one. Maybe it's 6 out of 24. And I want to simplify this. I want to make these numbers smaller. What I'm going to do is, I'm going to look for, instead of sort of making them speak the same language, we're going to look for a language that they both speak. And to do that, I'm going to divide. Now, both of these numbers can be divided by, can you think of one? 2. They can both be divided by 2. They can both be divided by 3. 3 times 2 is 6. 3 times 8 is 24. They can both be divided by 4. Oh, sorry, no, they can't. 6 cannot be divided by 4. But they can both be divided by 6. 6 divided by 6 is 1. 24 divided by 6 is 4. So that's what I'm going to do. I've discovered that they both speak sixths. Sounds like Sith. They both speak Sith. They both can be divided by 6, which will give me a new fraction. 6 divided by 6 is 1. 24 divided by 6 is 4. So my final probability is 1 out of 4, 1/4. Of course, you might not be able to figure out that number straight away. So what you can do, let's do 6 out of 24 again. If you want to, you can just divide by a number that you know for sure. So maybe you didn't get up as high as 6, maybe you just divide by 2. So then I've got 3 over 12. 6 divided by 2 is 3, 24 divided by 2 is 12. And then maybe you can divide again. I know that you can divide both of these numbers by 3 because they're both in the 3 times table, and then we've got 1 out of 4. So you end up in the same place even though you just took a few steps to get there. That's totally fine. When you're simplifying year 5s, you don't need to do it all the time. I'm accepting answers like this, 6 out of 24 or 3 out of 6. That is fine with me because I'd rather focus on the probability than also include a little bit of fractions. But if you want to go ahead with some fractions, this is your opportunity, and challenge yourself a little bit and get up there into the flying and blitzing levels if you can. Okay, thanks year 5s. That's all I wanted to tell you today. Keep using the strategy, how many you're looking for out of how many different things you could get. Different possibilities. And if you want to simplify, look for the language that they both speak and divide, and then you get this fraction with smaller numbers. But it actually means the same. Okay, there you go. Thanks, mathematicians. I'll be on Zoom soon, and you can post in the forum if you have any questions. Otherwise, good job, and I'll talk to you soon. Bye.